Welcome back, everyone. This is Dr. Gallenstein, and here we are with the RStudio demo for lecture number 8. Now, in lecture number 8, we look at binary dependent variable models. And so in this demo, I'll just show you how to run the linear probability model and the probit model using R. As is typical when you're using R, you might need to install packages that have useful commands. So today, be sure to install these packages, and then make sure you use the library command to inform Stata what packages you want to use. So I'm just going to hit all of these here, and then I'll go ahead and import our data. In most lectures so far, we've used the wages data, but this time we're going to use this college graduation data. The college graduation data has information on whether or not individuals graduate from college, as well as a bunch of other variables that we will use to model the probability of graduating from college. Okay. And so the first model that we can use is the linear probability model. The linear probability model just uses ordinary least squares to estimate the coefficients of the model. It basically treats the binary dependent variable as a continuous variable. And so it really is very straightforward. We've seen the code for running OLS regressions before. So here's the simple code. We create the model, and then we produce the results from the model using the summary command, or we display the results. The model here is just very simple. We're just going to use the binary variable UD equals 1 if you have a university degree, 1 if the observation is a university degree, and 0 otherwise. And we're going to regress that on parents' income, parents' education level, and the student's GPA. And of course, we got to tell it what the data source is. So let's go ahead and run that. Generate the results. Now, one nice thing about the LPM model is that it's very easy to run, and the interpretation is straightforward of the coefficients. So I'll just interpret some coefficients here just for practice. So we see we have 3 independent variables. I'll just go through a couple of them. So let's do GPA. So we can see the GPA is definitely statistically significant. So then we'll go and interpret the coefficient. So the way I would interpret this is that the probability of graduating with a university degree is 0.18 percentage points higher for each additional GPA point, holding all other variables constant. Okay, so put another way, the probability that a student graduates from college is 0.18 percentage points higher for every additional point of GPA that they have, holding all of the factors constant. Okay, doing education, so this is the parents' education. So here again, we see it's statistically significant, so we'll go ahead and interpret the coefficient. So the way I would do this is I'd say the probability that the student will graduate from college is 0.015 percentage points higher for each additional year of schooling that their parents have, holding all other factors constant. Okay, so there we go. That's the interpretation of the coefficients. Moving on, so the disadvantage of linear probability model is that the predicted probability doesn't necessarily, and often doesn't fall between 0 and 1. So if we need to predict the probability that any individual has a university degree, the LPM will generate incoherent probabilities. The probabilities should be between 0 and 1. So I'll just go ahead and generate those predicted probabilities. I'll save them as a variable inside the college data set, or the call data set, call it LPM pred for prediction. I'll just show you what it looks like. So here's the predicted value. You can see right off the bat there's a negative predicted value, so that doesn't make sense as a probability. Okay, so then if we really need the predicted probabilities, then we're going to have to move away from the linear probability model, because that does not generate coherent probabilities. So instead, we might use a probit model. So let me show you how that works. Largely, it's very similar. So I'll create a probit model. I'm going to call it model1.pb, pb for probit. Instead of using the lm command, which we used for OLS, I'm going to use the glm command. But then inside the command, again, it's very similar. So put in the model here. So like before, the dependent variable, just repeating the same model. So the dependent variable is binary, equals 1 if they have a university degree and 0 otherwise. And that's regressed on income, parents' income. education or parents' education, and the student's GPA. So I just have the model in here. And then I have the data set, indicate the data set. But then I have a couple of additional points that we need to put in here to inform R that we want to use a probit model. So this command here informs it that we want to use a probit model. Okay, so let's go ahead and run that, report the results. Okay, so like I said, the advantages of the probit model is that it generates predicted probabilities that are between 0 and 1, so they make sense as probabilities. Now the downside of the probit model is that the coefficients they do not have a clear interpretation. They can't be interpreted as marginal effects. So we're going to have to produce marginal effects, which I'll do in just a minute. But first, let me show you the advantage of the probit. I'll generate the predicted values for the probit model. When I'm doing that, I have to include this additional comment here. So I'll do use predict, put in the model name, and do comma type equals response. That's just an extra thing you need to do when you're generating the predicted value from the probit model. I'm going to save this predicted value as a variable in the call data set. I'll call it prob.pred. So that's the predicted value for the probit model. So I'll go ahead and run that. And then what I'm going to do, just to illustrate the point that I'm making here, I'm just going to use this describe command to generate some descriptive statistics for our data set. And so I'll come down here and just take a look at these two predicted values. So LPM pred, that is the predicted value from the LPM model. And then prob pred, that is the predicted value for the probit model. And we can see here that the predicted values do not make sense as probabilities for the LPM model. We can see that the minimum is negative 0.35 and the max is 1.47. So the min is below 0 and the max is above 0, or I'm sorry, above 1. So those don't make sense as probabilities. But prob pred, that's the probit model. The predicted values do make sense. They fall between 0 and 1, and so they make sense as probabilities. Okay, now to overcome that shortfall of the probit model, we need to generate the marginal effects of the coefficients so that we can interpret them. To do that, I'm going to use this probit mfx command. This command comes from the mfx library. So I already loaded that library earlier. Just want to make that clear. So let's go ahead and run that. In this, so this command probit mfx, this just produces the marginal effects from the probit model. You put the model in there in the data set. So let's run that, report that. So here we go. Here are the marginal effects for the independent variables from that model. And so we can interpret these in the same way that we interpreted the coefficients from the LPM model. So I'll just do one as an example. So GPA, this is significant. And so I would interpret this coefficient as saying that the probability that a student graduates or obtains a university degree increases by 0.29 percentage points for each additional point of the student's GPA, holding the other variables constant. Okay, so there we go. That's the probit model with calculating the marginal effects. The last thing I want to do is I just would like to show you how to calculate the pseudo R squared. So when we use a probit model, we don't have that standard R squared value. Instead, we use the pseudo R squared. R doesn't report that automatically, so we just need to produce it ourselves. We'll use this. We will install a package, pscl, call that library, and then just use this simple command pr squared. So that is the pseudo R squared. Let's just run that. And what it does is actually gives us a number of different pieces of information here. But what we want is the McFadden pseudo R squared. And so there's our pseudo R squared for our probit model. And lastly, I'm just going to use Stargazer to present the results from Model 1. So here's our linear probability model. What I have here is I have the covariate labels. So actually I've given some nice names to the different variables. So I've given them the full explanation: parent income, parent education, student GPA. I've given a nice title here: college graduation analysis, reporting the observations here. So here's a nice visual presentation of our LPM model. We could do it for the probit too if we wanted. Okay, great. That's it for today. I hope everyone enjoyed the lecture, and I will see you next time.